Chapter 12, Solutions. Wouldn't it be great if this was a chapter about all the answers to all of our problems?
Yep.
Yeah. Solutions, right? Solutions to our problems. It's not that, yeah, you see that? It's not that kind of solution. Yeah, that would be too long. Anyway, section 12.1. You probably know, hopefully you know, you should never drink seawater. You might think, well, why would anybody want to? It tastes nasty. Well, if you're stuck in a boat in the middle of the ocean and you have nothing to drink, it could look a little appealing. It actually is going to make you more thirsty and more dehydrated than drinking nothing. And that's because seawater is a thirsty solution. So we're going to talk about solutions and some of their properties, and we'll eventually get to why salt water does that to you. But what is a solution? A solution is a homogeneous mixture of two or more substances. So homogeneous, the same throughout. And it's a mixture, so the proportions of the different components can vary. They're not always going to be the same. In seawater, water is the solvent, and sodium chloride is the primary solute. So these are the names of the two different components of a mixture. The solvent is always the thing that there's more of. And usually that's liquid, but not always. Sodium chloride, no, that's not what I was going to say. The solute is the stuff that's dissolved in the solute. So in seawater, it's mostly water, and then it's got sodium chloride ions floating around, distributed uniformly. So that's what a solution is. Nature has a tendency toward spontaneous mixing. This happens in my house. I'm sure it happens in your house too, right? If you put a bunch of different colored socks in the washer, even if you put all the red ones in first and all the black ones in second, when it's done washing, they're just going to be completely mixed up, aren't they? Things just mix together, and that's a natural tendency. So in this illustration, we're showing a container here with a divider in the middle, and on one side we have pure water, on the other side we have salty water. When we take this barrier out, even without stirring, those two solutions are going to mix. Now, it may take a little while without any stirring, but they will mix and become a uniform concentration. And that's a natural tendency. When you drink seawater, you've got, this is actually an illustration of your intestinal tract. So this is inside your body, and this is in your intestines. Have you ever thought of the fact that actually your stomach, your esophagus, your intestines is actually the outside of your body? It's one long tube going through you, isn't it? It's not really inside your body. Something to think about. Anyway, this interior of your body cells have a certain amount of salt in them. And here we've got seawater in your intestines, a more concentrated solution. The walls of your cells are semi-permeable, meaning they allow some things to go through and not others. And so water molecules can go through those cells. So water will be flowing into your intestines. Water can also flow from your intestines into your cells. But because of this tendency towards mixing, what happens is when we have a low concentration here and a high concentration here, the water is going to flow mainly in one direction into the more concentrated solution. You can think of it as nature's trying to equalize the concentration. It's like here's high and low concentration. We don't like these things separated, so we're going to put more water over there to make it less concentrated. Well, what does that do? That causes your body to lose a lot of water. I'm going to go back to that. It just didn't seem like a finished thing there. So if you drink seawater because you're thirsty, but it actually pulls more water out of you, it's going to cause you to become more dehydrated. than if you didn't drink anything. Still not real happy with the end of that, but that's just it.